So Chapter 8 is about periodic properties of the elements. Skipping Chapter 8, Section 8.1. Can't remember why, but obviously I thought it was a good idea at the time. You should read it, but it won't be on the test. So Dmitri Mendeleev, he's given credit for being the father of the modern periodic table. He lived back in the late 1800s, died in the early 1900s. Yeah.
Do we have to know that?
No. I do not test you on people's names or when they lived. But I think it's good to have heard of these people because they made some pretty significant contributions to science. So Mendeleev ordered the elements by atomic mass and saw that there were repeating patterns. We've talked about this. It's the periodic law. When the elements are arranged in order of increasing atomic mass, certain properties recur periodically. And that's why this is called a periodic table. I know, coming up through school, I never really thought about why is it the periodic table? It's because the properties repeat periodically. So he used the patterns he observed to predict properties of undiscovered elements. Back in the late 1800s, we had not found all of the elements that we have now. They were there, but we just hadn't discovered them yet. So he predicted the properties, and we'll look at that. And there were a couple of places where the atomic mass order didn't fit the other properties, and so he followed the other properties. And one example of this is tellurium and iodine. And if we find tellurium and iodine on the periodic table, we see that tellurium comes before iodine, and yet its mass is larger. Tellurium is 127.6, iodine is 126.9. So going by mass, iodine should be first. But he recognized that that didn't fit the properties pattern that he was seeing. So we found out later that atomic mass is not actually the ordering principle. So Mendeleev made predictions like this, which are pretty impressive. So he predicted the existence of gallium. He called it eka-aluminum because it would be below aluminum in the periodic table. So his predictions and the actual properties match up very, very closely. He predicted the formulas of the oxides and the chloride, the density, he nailed it, the atomic mass, really, really close. He also predicted the existence of germanium. He called it eka-silicon because it would be below silicon on the periodic table. And again, he made excellent predictions about the properties of that element. So we've talked a lot about what versus why. What is the laws? The laws tell us what happens. Theory tells us why. Models explain why. So the periodic law tells us how to predict what the properties are, but it doesn't explain why the patterns exist. And the quantum mechanical model is the theory that explains why the periodic properties exist. When we know why, we can predict what's that have not been observed yet.